In this chapter, we can understand nature of digital information, digital fundamental, binary coding, binary numbers, digital text, digitizing document, scanning, image compression, character recognition, analog to digital conversion, digital audio, digital video, digital format, document format, image format, audio format, video format, legality of digital documents. These are the components we are going to cover in this talk, in this lecture. Now, electronics information in digital form is called digital information. So, when information in electronics information in digital form is called digital information. In many texts, no distinction is made between the electronics information and digital information. So there is no such any kind of differentiation on the digital information and the electronics information. This is a concept of digital technology. Here you can see digital technologies, digital marketing, email, social media, SEO, campaign. This is basically concept of marketing, but if you want to see the form of digital information is in a different way. Somewhere you are getting information in televisions, you are writing email, you are in the WhatsApp, you are in the Facebook, in social media. Coming to the digital information, we need to understand the nature of digital information. Here we can see a digital document may contain information in the following form: digital text, digitized text, digital image, digitized image, digital sound, digitized sound, digital video, digitized video, computer animation, computer generated drawing. So these are the concept of the nature of digital information. Now, what do you mean by digital fundamental? The underlying, the representation, storage, and communication of information in digital form in the binary system. In the binary system. In binary system, we have only two symbols, 0 and 1. It is interesting to know that we can represent any information by using just two symbols. Any two symbol, say P or Q or beta, alpha and beta, could have been chosen arbitrarily, but the digit 0 and 1 are chosen because they can be represent both numeric and non-numeric information, and binary arithmetic can be performed on the numerical quantities represented by zeros and ones. But interesting thing I will tell you, why 0 and 1, through 0 and 1, basically you could understand, the machine is understand very easily. When we write A, so machine understand it is 1 off, 2 on, 1 off, 2 on, 1 off, 1 on. So 8-bit digit. So 0 means off, 1 means on. So 0, 1, on, off, the concept of the digital concept. So every time the job of the microprocessor is to process this machine language into the assembly language, right? In binary coding, you could understand the underlying ideas in information representation is that we form string of two symbols of any desired length and placing a meaning to this string. This is called coding. We are coding known information as binary string. Then a sequence of string may represent a meaningful message. For example, consider the following string with their pre-assigning meaning. Here, 0001 A, 0011 C, 0000 P, 0100 T. So, pre-assigning digit for A is 0001. So, this is a pre-assigning. Here you can understand, if it is hello, my name is that. Hello, my name is that. That numbers, the digit 0, 1 off on is representing my name. So that's the interesting part of that, because my name in natural language is something, but when we make it understand to the machine, then it represents right that way. Okay. Here you can see a coding scheme for day of the week and rainbow colors. Sunday 000, violet 001, Monday 001, indigo 010, and Tuesday 010, blue 011, Wednesday 011, green 100, Thursday 100, yellow 010. Right that way, these are the predetermined or pre-assigned binary code for those days and colors. Here is the binary numbers. Let us now turn our attention to see how we represent the number using binary digit. As you are aware, we use a place value concept while representing number in decimal system. For example, the number 5657 has a value equal to, this is 5 into 10 to the power 3 plus 6 into 10 to the power 2 plus 5 into 10 to the power 1 plus 7 into 10 to the power 0 is equal to 5000 plus 600 plus 50 plus 7, 5657. That's the interesting part. So you can differentiate right that way. Here is a digital text. Text, context of alphanumeric and special character. In English language, we have 26 uppercase and 26 lower cases. Letters in the alphabets. Indo-Arabic numerals have 10 digits, 0 to 9. There are special symbols like plus, minus, and star, percentage. All these add up to a total of 95 characters. We call this sum total as a character set for text with a 6-bit string. We can have a maximum of 64, 26 combinations, which are inadequate to represent all the characters in the text character set. So digital information, you can understand, it's always count to be a kind of 64 bits kind of thing, because in 26, you need to have a 26 combination. That's why it's represents like 64. The most widely used 7-bit code, American Standard Code for information interchange. Sometimes you will find in your computer, it's a different kind of character is coming up. It's differently paced, some different kind of character. So these are basically called ASCII code. ASCII code is immediately presented from the binary. Equivalent to Indian Standard Code, we have also Indian Standard Code for information, ICCICII. Since we have only 95 characters, we are left with a 33 combination in a 7-bit code, which can be used for some other purpose. Other than ASCII, there are code sets that are in use. One such well-known code set in extended binary code and decimal interchange code is EBCDIC, used for large IBM computer. EBCDIC is also an 8-bit representation of the character. ASCII also have to be sometimes 8-bit, obviously, but it was 7 bits, of course, in the near future. So you can understand these are the standard code for information interchange. So American Standard Code for information interchange is called ASCII. Today's date, information are born digital, but previously it was not like that. It was non-electronic document, printed document. So today's date challenge is how we are going to digitize all those concepts, all those documents, all this information. So unless you digitize all those documents, it is not going to be a popular. It's not going to be a common man. And if your information is not going to be a common man, so this information has no value at all, because unless anything in the world which is not kept for the well-being for the human being, it has its no value. So in that context, you understand the non-electronic document, it's digital imaging, then compression, then it's become digital document. We often do it today's date, even almost we are doing every day. Here you can see how we can do it. What we have done in our library, whatever the new product development and the project report was done by the student, we take everything. And we take everything, then we scanned it, the document being scanned. And after scanning, we put it into the PDF file. And in PDF file, we started scanning on, cleaning on that. Once it's become clean and refined, then same document profile with a tag should be accessible. And how this is going, it is going to be accessible unless you tagged it. That means unless you create an index for them, it is not going to be retrieved easily. So you need to have a tag. What are the important terminology along with this document and how you are going to tag with that. In that consequence, you tag, then you are going to save in a place, either in a digital hard disk or one copy being kept into the scanner, and you can scan it with a different DPI. Asthma of DPI means dot per inch. Dot per inch. Dot per inch means it as many as dot in the pictures, the resemblance of the pictures is very high. So resolution of the pictures become very high. It looks like live picture. It's more, so it's almost like high definition kind of thing. So you can scan on the base of the DPI. In case of pixel is concerned, suppose you are going to scan a photography. There dot or pixel is important aspect. So this is, and dot and pixel is synonymously used, the same terminology. Now this is a scanning kind of thing. You just scan over there, and you can scan in a different mode: 600 DPI, 1200 DPI, 2400 DPI. As much as DPI the resolution of the copy will be more refined and very reflective. And in case of image compression, scan image file generally very large in size. This is important aspect when you scanning, because once you scan, you need to keep somewhere. And suppose it's when you're keeping somewhere, so you need to have a place. And if you have a many things, then you require bigger place, bigger space to keep all those things. So scanning image generally very large in size. Consider scanning a postcard size 6 inch by 4 inch photograph using 600 DPI scanner. In 6 inches there are 3600 pixels. In 4 inches 2400 lines. Were assumed bit depth of 1 byte. The size of the scanned image file work out to be 3600, 200, 1 is equal to 86,400 bytes. 16 such picture could occupy entire floppy. So the floppy is 2 MB floppy or 3 MB, 4 MB floppy. So 3-4 pictures could occupy whole of the floppy. Today's date floppy is not being used, but floppy was almost a kind of medium where usually kept different document file. Today's date it's pen drive as you were using, we used to do in a floppy, storing the entire document, the entire thing in the floppy was our. So we usually keep backup in floppy. Today we are taking backup in pen drive or hard drive. So storing scan image, as they would need a large amount of storage space. In order to reduce the storage requirement of an image, scanning is always followed by compression before storing the image. There are two broad classes of image compression technique in compression: information preserving technique and approximation technique. Here we can see the compression kinds of things. Here, original JPG 824, 50% less compression 76 kb, 80% less 38 kb, 80% of that, right? So this is the way you can compress the JPG file. Here is the important aspect of the scanning. When you are scanning station and where you import the document, then it goes to the step to recognitions, then verification, then it's become index, and then export in the hard disk. And here you can see the verification stations and indexing station. So one place scanning is going on, then verification is going on, then indexing is going on, then it is going to the place where study material, the scanned document being kept. Now, this compression efficiency of a technique measured by the parameters called compression ratio, CR. It's called defined as CR is equal to size of the compressed image and size of the compressed image, both uncompressed image and compressed image. Most of the compressed software package produce compression ratio in the range of 10 to 20. Some very sophisticated packages produce a compression ratio in the range of 40-60. We now discuss some aspect of the coloring in scanning. Human vision recognize radiation of the frequency range of 1014 or 1014 Hz. It is the range that frequency of the main colors of rainbow vigor just a violet and that's lines. Now, character recognitions. Consider scanning one line of a text containing 60 characters at 600 dpi resolution. Let the highest of the character be 0.25 and the line wide 8. The size of scanned image file work out to be 608, 608, and 600 0.25. So it will be 7,200 bytes. In this section, we'll able to understand if the line of text were to be stored in ASCII character, then we can require a space of only 660 byte, 120 times lesser space than the scanned image. Here, character recognition, OCR, digital image, character recognition, and text file, obtaining text file from image file. Then optical character recognition. You understand the optical character recognitions. Here you can understand how optical character recognitions work. It's very simply. When you are, okay, probably many of you usually pay through the Paytm, and in Paytm, what you usually do, you scan a QR code. When you are scanning a QR code, it's basically optical character recognitions. The process of converting image into machine printed to handwritten text into the computer accessible format. Processing by machine of text based in input pattern to produce a meaningful output. I will tell you, in the barcode, normally in the library, when we usually use it's become a very obsolete technology. Now, through barcode, when you are reading one barcode, that is basically optical character recognitions. Then graphic. Graphic is important part in the digital information. There are many softwares which produce graphic, and in graphic you can create web graph kind of things, and there are web processing, Adobe Image. These are the software, and to the graphic software you can design the pictures and everything. Here you can see one of the Adobe Photoshop. It's basically and compressed or kind of technically they design and refresh a photographs through that particular software. Today's date, every studio where you click the photograph for your passport size, you will see immediately they take the photographs and immediately they download it into the computer, and they usually open up with the graphic software where they usually refine your photo. very nicely. Then coming to the animation, animation is a sequence of image and frame which display over time. So we often in our childhood experience the Tom and Jerry, and there are many stories, Bhim kind of things, and there are, I forget many things, but animations makes us uh, very happy, specifically for the children, or even sometimes it's appeal to the senior people also. Animation is nothing, it's a representation of the character into a dramatic way. So in animation, things are moving like a pictorial movement are there. So in for animation, there are many softwares working on that. Here, this is a one animation. So people usually do different kind of animated, and when you create an animation, you need to give the picture as well as the sound and music sometimes. So everything you need to one input through a software. Now, in animation, you can understand the concept of, there was a movie I have seen in 3D, Krishna. It was, I do not know who has produced or directed, but there I can understand the concept of three dimension. Three dimension, normally, whatever we watch in a two-dimensional concept. But three-dimensional, almost it makes you a feeling that you are on that particular event. So you are on the deep event. So in animation, majority animated films today's date, it is coming 3D, 4D, 5D, 6D, 7D. So it's a kind of virtual reality kind of thing. But dimensionally, they always stay at 3D. In 3D, the appearance of a particular picture is coming so real, it's feel like that you are on that part of the event. And at the same time, the most important aspect of the 3D is to designing in any complex machine, designing any building structure, complex building structure, where you require the three-dimensional. Otherwise, a person could not understand what exactly they need to do and how they are going to affect. So this is a kind of software which people are using for the different engineering design also. Now, some of the three-dimensional softwares, Maya, Soft Image, 3D Max, Hound, Cinema 4D, Lightweb, Animator Master, Carrara, True Space 7.6. These are the three-dimensional animation software. And here is a two-dimensional software, Adobe After Effects, Anis 1.0, Benton Movie Chip, Silex 2.9, Digicel, Flipbook 6, Class Effect Site Builder, Class Media Show, Photo Morph, Zip Splitter 2. These are the two-dimension. In audio video software, in audio video is now available in digitized form and played with the computer. Song, speeches, where we listen from the tape recorder or the radio, or in the analog form. Digitizing of audio can be done by attaching an audio player to a system through an audio capture card. With the sound can be recorded in the system. I will tell you one interesting thing. Those who have seen the record player or cassette player, that was basically a analog concepts. When all those things has converted into the wave or sound form, digital format, MP3, MIDI, then it's become digital. Video capture in the normal camera or the real camera, it was analog. When today's date, probably you have seen the oldest camera carry some kind of reel behind it. So before clicking any photographs, we need to put kind of reel on that, and that reel, when finished, it will send it to the laboratory for the refinement, and we got printout of those reel. But today's date, the camera is coming in different way. It's digital inborn. Here, some of the photographs where we can do videographs. And normally when I am talking to you and talking to you, that whenever I'm lecturing this video and when I'm talking about the editing of the video, that so after doing this thing, we take the take the whole video together and we put it again into a one video editing software. There we edit right there. So this is one video editing software where we can take the video. Now, digitizations of analog audio and video, that's the most tedious job. Today's date, suppose any singer singing a song, it is recorded in digitally. But think of that when Lata Mangeshkar madam sing a song and it was on analog form. Now, today's date, we have to put all those songs of Lata Mangeshkar or Kishore Kumar. If we want to take their song and if we want to put into the internet or in the web, so we need to transform all those analog song into the digital, because that was recorded in analog form. In case of camera, suppose we want to convert it, today's date, whatever the movies is producing, film, it is on the digital form. But if we look back, if we take the movie Mother India, that was very oldest movie, but that movie was in an analog format. But if today generation want to see that movie in their computer, so we need to transfer all those movies into the digital. So it was a tedious job. Now, how we are going to digitize all those things? If you look at that, you can see the record player here. We normally record through record player. It is an analog mode. Through analog mode, we take out their song, we put into the input into the computer, and through computer we digitize that particular song, particular music. So this is the way we digitally. Today's date, everything born digital, but if we have look backward, so we can see that everything was in analog. We need to transfer into digital. That was the job. Now here you can see the same thing is applied in case of motion picture. In motion picture, what happened? Previously it was in analog format, and we have to convert it in digital. Then after we can make sure that our generation will see. Otherwise, they don't have a time to see, because your technology not going to permit that to see that kind of movie analogy, because the technology become obsolete. So we need to digitize all those things. So here is the digitizations of things, the movies. Now there are many formats. First, I have seen the format was web format or movie format, then MPG1, then it's came into, this is basically motion picture expert group, MPEG, MPG1, MPEG2. Now it is MPG. Then it is three is kept for the media, but only the music, right? Then MPEG4. 4 is today's date. Whatever things is you are saving any video, it is saved in a MPG4. In sound, MPG3. Last time I have experienced, I used to save the audio format in WAV, wave format. Then today's date, if it's in MP3, MPEG, video can be stored in 3 possible layers. So the most popular way. So what MPG means, here you can see MPG means, sorry, motion picture expert group. Here you can see MPEG means motion pictures expert group. So that's why MP4, that's why MP3, right? Then multimedia authoring software. Integration of audio, video, graphic, animation, and text is known as a multimedia software device for production and presentation of the complex interrelated video object. Has got extra importance and is called multimedia authoring tools. Hence, a multimedia authoring tool is the means that allow multimedia presentation, which synthesize content created by the text, graphic, video, and audio editing tools into a single presentation. There are broadly 4 categories of such software. Here is card or page-based tools. Multimedia software elements are organized in the case as a page of a book, a stack of a card. This best use when bulk of content consists of element viewed individually, where hyperlink enables user to browse in a non-linear way. For example, hypercut media object, and toolbooks, etc. This is a card or page-based tools. Second, time-based tools. Event and elements are organized analog or timeline. These tools are best used when message or information must be provided within the fixed time limit. An example of this kind is Macromedia direction. This time-based tools is based on the time frame. Then object-oriented tool. Here elements and events become objects that lie in a hierarchical order, parent and children relationship. This is particularly useful for the game, which contain many components with many personalities. The best example are Metropolis, Apple Media Tools, and Media Forge, etc. This is examples of the object-oriented tools. Next is icon-based tools. In this case, multimedia element are user interaction are organized as object in a structural framework. These tools actually help in organizing the content by displaying a flow diagram of activities along with the branching path. The best examples are authorware, iconware, quest, etc. So these examples of the icon-based tools. Now, as far as printing software is concerned, printing is a drawing and printing software supplied with a window. One can create simple and elaborate drawing. These drawings can be either black and white or color and can be saved as a bitmap file. To draw horizontal, vertical, and analog line, to use foreground, background color, and to use picture created paint. So everywhere you always have shows the printing softwares kind of thing. But interestingly, I'll tell you, there are many printing which is very important. If you go for the graphic printing or 3D printing, you need to have a kind of different software. Because if you go to the School of Planning and Architect, they have a different printer. It's a bigger printer, CAD-CAM printer, and connected with, it's basically designed the different engineering modules. So this is another area in digital information. Then bitmap image, you always experience that in your MS Paint. You can draw anything, you can save, you can make it save, you can make it save in different bitmap image, JPG or PNG, any format you can able to. But if you go for the Coral Ventura and Coral Draw, it is specifically for the drawing kind of thing because it has its more feature. So it's a help for taking one of the finest graphic picture. Now today's date, communication softwares with the advance of networking and email, we need to have a, if you do not have Internet Explorer, Navigator or Mozilla Foxport in your computer right now, you are not able to access internet at all, because that is the base of internet communication. So this is basically called Explorer software or communication software, internet communication software. Here you can see some of the examples of the internet. It's Chrome, Firefox, Chrome usually very popular, Internet Explorer of course very popular, Concora, Opera, Safari. These are the also communication software which through you can access internet. Then OCL, optical character recognition software, where it has its many software depending upon the applications of the software, but it's again based on the DPI and and other feature also. So the most important aspect, it's compatibility. In graphic, photo, logos, and drawing are example of the graphic. Text formatting, the, what are the features, capacity? Uh, is that it has graphic, text formatting, or page formatting options or not in the OCR software? It's very important. Here is some OCR software: Adobe Acrobat, Newsers, OmniPage, Pro DC. These are the software basically kept for the OCR software. Then coming to the markup language, you know HTML kind of thing. What exactly the markup language? It helps to designing the web pages. It's help to designing the web pages. In markup language, you can see markup language are not programming language. These are widely used for the web authoring. So whenever you are writing a web page, you need to have a one markup language. Now markup implies a process involved in combining simple text or information and some special symbol. So it's very easy tools for creating kind of, you can put the pictures, different content, you can format on that, you can have different presentation on that. So this is all about the markup language. What is a markup language? This is an example of the markup language. If you wanted to represent these things in a way, this is the best way to markup. Now, in markup language, you will see there are two categories: one, descriptive and procedural markup language. Descriptive markup language is to describe the structure and behavior of the document, allowing the authors to concentrate on the content and structure. The markup tags are used to describe the structure of the corresponding text, which is otherwise known as object. Procedural markup language gives more emphasis on formatting and presentation than its structure. That is, markup languages carry the instruction for the text processing are known as procedural markup language. SGML and its origin. If you standard generalized markup language, SGML is a superset of all other markup language. It is a highly detailed and complex system of presenting information that is designed to allow content to be platform independent, and is powerful complex tool for representing document for all kinds. So SGML was originated with the work begun in IBM in 1960s, and today's date basically everybody they're more focused in the SGML than any other software. Here you can see SGML was originally targeted for the local use at IBM rather than the generic way of representing document. This was multi-platform strategy for document preparation, a concept that was become extremely popular. Charles Godfrey, E.D. Moser, and Ray Lowry originated GML by the 1970s that a more general version of the markup should make document portable from one system to other. Their work led ultimately to the definition and birth of SGML in 1980s, which is covered today by ISO 8879 standard developed 1986. Several business organizations, commercial and government institutions have adopted SGML. SGML is a very popular language today's day. Now, this is a structure of SGML. User may define their own tag and syntax. It's very easy and open tool kind of thing. Now, coming to the, after doing so much of thing, you have digitized, you have draw a picture, if you have transformed analog to digital, you have created the pages, you have created a picture, you created the movies, motion pictures, drawing, you are digitized. Now, what is the responsibility? What is the legality in digital document? The legality is integrity. Integrity means it should not be copied from anywhere. It should be from within. Or if you copied, you must recognize that this has been copied, but I have transformed this way differently. Then when we have integrity, then we have to give the power of accessibility. If there is information, if it doesn't have its accessibility, so it has its no meaning. So we need to create a kind of information infrastructure that information could retrieve properly. The accessibility of information can be done very smoothly. Otherwise, it cannot save the time of the user. It cannot save it cannot your organism cannot be growing. So we need to have it, unless it is become accessible, then every information its reader, and every reader his or information cannot be possible. So accessibility is another important area. Then confidentiality, strictly confidential, secret, and top secret. This is more important. I will tell you one important thing. In normal way we are using internet, world web, but this world web, it's appear to me it's different way, but some people they are using different way. There is a concept called deep web. It's bigger than the web which we are thinking, because deep web means it is a 10% of the total internet which we are watching, and deep web means it is 90%. So you understand what is happening throughout in the deep web. Now here we can understand the content. Which content is strictly confidential, which one is secret, which one top secret. So we need to categorize all those documents and we put forward for that. Then copyright. Information is important, but at the same time, copyright of that information is another important aspect. Unless we copy out, make that information, it cannot go further. Everybody can copy it and they can use for their own way. So, and we have to look forward when we are digitizing anything. Suppose in case of digitizing, suppose you are thinking you are going to digitize all book of your library. No, it cannot be possible, because every book has its copyright to the publishers. If you want to scan the book in your library and put it in your hard disk, if the publisher get to know that you have already digitized that book, then probably you can face the consequence. You cannot do that because that is his copyright. If you want to do so, you need to take permission from that publishers. So we need to follow the copyright rule. Neither we take anything without asking anybody, or neither will give anything free. Because if I create anything, that need to be my copyright right.